Uh, Thinking of a technology where we can actually give data and insights to insurance, farmers, agro businesses in general to become more resilient to climate events. I think that's could be it's an ultimate goal for us to get.
Today we brought on two co-founders of a Techstars company called LambdaI Space. Welcome the CEO Antonio and CTO Raul. LambdaI Space is a climate-resilient agriculture AI venture combining satellite monitoring with physics-guided analytics. The technology transforms climate impact assessment for farming. Today, we explore how LambdaI helps insurers and governments assess agricultural climate risks and discuss impact assessment, insurance applications, and remote sensing capabilities. This is Earth ABC featuring Antonio and Raul.
All right. First, I just want to thank you guys both, Raul and Antonio. This is our first interview where we have two co-founders on our call, so very exciting. I'm really looking forward to learning more about how you guys are working at the intersection of AI and remote sensing to essentially figure out climate impacts on agriculture. So really appreciate you guys for being here.
Thank you,
Thanks for
Sean,
having
for
us, Sean. Thank you.
being here today.
So firstly, I want to talk about the problem itself. How exactly are you using AI and satellite imagery in the application of agriculture? Like, what's the big problem here?
I can get started with the part of the problem, and then we can also, I think Raul can expand more on the technology side when he's giving his input. So there are some challenges. I mean, the one that we have noticed in our experience, it has been where when the satellite imagery or remote monitoring is needed at scale, it becomes a big challenge for uh, for whoever basically plays roles in agriculture. The whole supply chain. We're talking about insurance. We talk about financial service in general, governments. So they face big challenges when they want to apply those remote monitoring at scale. And it becomes extremely expensive. And there is also indeed some of the use cases that become not accessible.
I see. So it isn't like the farmers who are requesting your software per se, but it's like these insurance companies, these governments instead.
Yeah, so the key target for us are insurance, financial services, governments, not the farmers directly.
But I would say, if I can add, I think the farmers is just because it's typically a segment that is very hard to convince about the value that it can bring. So it has some, let's say, adaptation period as the technology evolves, right? So the same way that the mobile penetration at the beginning was kind of not very high and suddenly really took off, especially in areas that were very remote. I would expect that, with the advances that we are seeing in robotics, in AI, is going to become just a part of the overall capabilities that will help farmers. It's just different timelines, right? So it has been more pressing probably for the insurance because of all the huge monetary implications that could have for them. So it's kind of a use case that is really solving a major problem. And for the farmers, I think in many cases, I mean, we find very high-tech farmers that are already using that out of the box from already, let's say, packaged solutions. And then we see like the same way that we think about enterprises and SMEs, there are a lot of small farmers that probably, it's as it's hard to really earn money in agriculture in many countries. They say, well, it's really worth for me to get that investment. And I think it's just because in many cases they haven't got realized about the value that could bring to them, or in some cases, actually, it's not really worth the return, right? But my personal opinion is that this technology, as we make it very accessible because of very low cost, it will really impact in a positive way farmers, and we will see that adoption coming. It's just a different velocity, I would say.
I agree with Raul on this actually, because if you think about there's at least aspect that is the ecosystem that somehow will nudge the farmers to start adopting these technologies. Because so they get an entry point for us, insurance will be faster because as I always say, they are the one that are paying the large, they are the ultimate risk takers, right? So they're the one that have to actually find a solution to do so. That's why.
I see. So the customers themselves, those are like the insurance companies, the governments, because they have money to invest into this like solution to monitor the crops and then the overall landscape. But then the beneficiary are the farmers. One thing I want to clarify is how exactly are the farmers benefiting from whatever knowledge is gained from Lambda AI?
Look, there can be this in my view. There is a few aspects of using. Let's say talk about uh, climate resilient solution in basically in this field, right? There is today a lot of practices are done to in a reactive mode, so that if an event happens, then technology or even human being are sent basically to a particular field to understand what happened and then quantify the damage and so on and so forth. Uh, Thinking of a technology where we can actually support, give data and insights to insurance, farmers, agro businesses in general to become more resilient to climate events. I think that's could be it's an ultimate goal for us to get to that level.
Mhm. So being able to provide like this like climate data for like forecasting purposes, so that these like farmers can essentially prepare for certain seasons in which like climate has been changing and adjusting their crop strategies.
Yeah, to adapt and adjust, right? And to understand with the by now having access to information at scale, so that is scalable, so which now is affordable. So you can start actually preparing for a possible extreme event. And understanding and Raul, I think what the example you made me once for the when we talk about phenology and understand how the health the technology we're using understands the physical property of plants, and it really can give you already insights about on an early stage where there could be triggers that could be flagged to the farmers, for example.
Yeah, and another thing I wanted to add is also the way this information is going to be consumed, and is connecting to the previous question, is also another aspect of the adoption. So you cannot go to a farmer and throw him 20 maps of the very different, highly technical, indexes that, usually are handled by data scientists. So the way we work with LambdaI, where we kind of translate all these outputs into, for example, a conversational driven interface like ChatGPT, like that makes the adoption and the interest and the value that can bring to the farmers way higher, because actually they can ask questions in their own language, in the language they understand. It's like, what's going to happen to my crops next year? And that has a lot of context and implications. So that simple question goes back to the whole system, and you say, okay, what's going to happen means, based on the past, based on the analysis that we have done, I mean, this is going to be the prediction. So when you have that in the palm of your hand as a mobile, which is the thing that they use, then that is a significant shift in the way that the information is valuable for the farmers, right? And the impact that can have to them. So it's just something that I wanted to add there, because that is where the technology really adapts to the needs and the understanding and the world of the final consumer, right? Which is the agriculture here.
Yeah, most definitely. And given how our climate is like changing a lot as of late, how will you plan to like adapt and scale your product to not only meet a growing demand, but also maintain accuracy and reliability of the AI?
I can take that. One of the, I mean, the really power of AI in general is the ability to find all those patterns that we as humans cannot really understand or see, right? So even the weather is kind of unpredictable. Actually, it's physics. I mean, it's just that the complexity is so high. So we're starting to tame the tame the beast of climate kind of forecasting. You have seen the works by Google in the last year, I think, a couple of months ago, where they were getting really very highly accurate weather models based on AI. And here is the kind of same thing, using the physics guided AI that Lambda, our company is working with. We're going to start to extract patterns that were impossible to see, like 10 years ago. And with that, we basically that alongside other models like this prediction of weather models, then it becomes almost like a crystal ball where you can really get a much better understanding of even kind of even preemptive in the way, like, okay, we start to see certain weather pattern that resemble something that happened like a couple of times. And that evolution based also on the understanding of the physics of the atmosphere and the physics of the areas that this damage happened, basically would allow us to really tackle the problem of uncertainty. So one of the things that Lambda is doing is really reducing that uncertainty, because we are getting access to the discovery of patterns that were impossible to do before, right? And that goes back to your question on accuracy. So we got very high uncertainty, reducing that uncertainty with the power of more and more sophisticated models and the amount of data that we have at our hands. Now that we are able to use a lot of open source data with this, in a way that basically is not as costly as if you were going to use commercial satellite imagery, it really makes that possible, because the AI models right now, they need a lot of data. Not only that, in some of the technologies that we use, the data is not so much available. So kind of the innovation we bring here is also the synthetic data generation that we use to train this model, that are very high fidelity, because we understand more and more the physics involved behind.
Gotcha.
It's also just to supplement that, Sean, like if you think today we are got to a stage that I think the technology, right? It's developed to a stage where we can achieve things that we couldn't achieve like 5 years ago, and also what we have now is a need, is an emerging need because of this growing number of climate events that is impacting businesses such as insurance and agro businesses. Well, just one example, and then more.
Mhm. So it's like a mixture of like understanding physics in like particular localized regions, and also the corresponding satellite imagery and the generated data that you come up with, since you are mainly working with open source data. Am I understanding that correctly?
Yes, because I mean, one of the problems is this open source data has been available for many years. The problem is it was kind of locked in the issue of, let's say, problem with the resolution that it had. So AI unlocked that kind of problem. And here resolution is not only spatial resolution, it's resolution also involving other parameters like polarization of light, polarization of radar signals. And because AI now allows you to really extract the information that you were unable to do before, it suddenly becomes so rich that really helps to address the problems that were intractable because of cost, right? Um,
Mhm. I see.
yeah.
And you guys are right now mainly in the Italian market, and obviously there, even in Europe, there's areas where there's different climate patterns. There's new geographic regions, and I know that we pretty much have global coverage with like satellites. But when it comes to these like new geographical regions, how do you address the cold start problem in your AI models?
Well, as you know, there has been a lot of advance also in generalization based on diversity of starting models that you already have run through. So the beauty of it is at the end of the day, plants are plants, you know, no matter what. So, even, although there are differences in geographies, differences in, type of, for example, type of rice in one place or another, at the end of the day, the physics of phenology are pretty similar for many different families. So this is another power of the generalization capabilities of new AI models and the ability to simulate the kind of, because we are using a lot of physics simulation for crops. So basically think of digital twins of the things that we want to observe, right? So the understanding, let's say the fidelity of these digital twins allow us to really train models very close to reality, and then using the power of generalization get to a very high level of accuracy. Remember that in many of the cases, business cases that we're looking into, you don't need a 99.999% of accuracy on variables. Even 80% is good enough from a business outcome point of view, right? So
Mm,
the technology, because of all the data that is available, the data that we generate, and understanding of the physics and phenology, is already good enough with all the computational power that is available to start getting to those levels of accuracy that are really good enough for getting very good business outcomes.
gotcha. I know Antonio here, he likes to garden. What do you think about Raul's statement that plants are plants at the end of the day?
Sorry, say it again.
I know you like to
What do you say?
garden,
Yeah,
and then Raul said at the end of the day, like plants are plants. So I saw you smile a little bit. What do you think of his statement there?
yeah, no, I mean, it's I agree. There is at the end when it comes to physics, um, it is plants are plants, right? So and having the opportunity um, to be able to scale this across multiple geography with the flexibility and thanks to the technology that's come forward to a level that today we are capable to do this. I think is really exciting for us, and we can't wait to really expand what we have globally. Um, we already having some conversation with the business across the world, like Southeast Asia, South America. Africa as well is another continent I think we could explore. And I think this is that it becomes extremely exciting.
Mm,
Yeah, something I wanted to add to this is if you see the evolution of the simulation of phenology, basically what it means is the parameters that determine the growth of crops or plants, the level of sophistication, the level of accuracy, because also machine learning are just staggering. So we're getting to such a levels of simulation combined with the ability to generalize based also on data that again give us the power to overcome traditional problems that you could see like 5 years ago. But now they are being unlocked because we have basically we have unlocked the problem with lack of data with synthetic data generation with these models and the availability of open source data that were kind of locked because of resolution issues. So all that is being unlocked, and suddenly it's like, okay, we, we are kind of getting access to a gold mine of information here.
mhm. And how far accurately can Lambda AI's AI models predict and simulate weather events and weather patterns? Because in my mind, I'm thinking that maybe you have high accuracy predicting and simulating like 3 years into the future, and then there's a drop off for the subsequent years. Is that the case that you're seing, or are
No,
you seeing
I
something
mean,
different?
we don't do weather pattern predictions. They're already models out there. We
Mm,
leverage that information on already predicted patterns, historical data. What we do is we give an understanding of the impact of the events based on those specific weather patterns, and then provide certain signals for the insurance or for the agronomers that we have seen this before, or this particular pattern has this particular impact. So you could predict potentially the severity of certain weather pattern that is maybe coming, but we don't predict the weather pattern itself. We basically work on, for example, in insurance, on our ability to assess, with very high accuracy what the impact has been, and with that kind of predict the future based on certain patterns that we're able to determine with a lot of data and machine learning. But
mm,
we don't do the weather prediction is something that Google is doing pretty well, right? So we really don't need to do that. But we aggregate a lot of data, weather data and other sources, to understand basically predictions of, assessing mostly the impact of, for example, hail or drought or things like that, and also kind of anticipate what damage you could see with certain weather patterns that are being observed, for example, or predicted by somebody else.
gotcha. Appreciate the clarification. I'm curious to know, like, for an insurance company, how exactly they'll be interacting with Lambda AI once, like, they understand, like, okay, I understand climate is changing. It's going to affect like crop yields. It's just going to affect the farmers in this region. I want to learn more about how I can best understand the impact of climate on the agriculture and how I could best prepare. So I know that you guys exist. How do I go about working with y'all?
So, I can share about that one question. So if you think there's a few ways that our technology can be leveraged by in this case by insurance companies. Um, so the first one you may think about underwriting. So insurance have to basically assess risk, and by essentially leveraging a few years, basically up to 6, 7 years of historical data about specific clients, they are in a better position to make more accurate risk assessment. So this is one of the way they can do it. The other part is assessing claims. So by using remote monitoring, they will not need essentially to have to send technicians to the field to assess the damage of a particular claim. Okay. Um, and the other one is when they are in terms of prospecting. So if you think about, there are particular areas that they would like to monitor because they might be potential clients. So by leveraging lower cost and scalable solutions, they can actually use the technology to be able to do that type of assessment. This is especially for brokers, which are the one that essentially sell insurance products, right, to their clients.
Gotcha. Okay, okay. And then in terms of, I guess, remote sensing as a whole, I want to like scope out a little bit. What do you guys see as the continued impact of remote sensing on climate insurance and sustainability?
That is a really
Mm.
broad topic, because I think we are just unlocking the very surface of what's possible with remote sensing. Remember that we are now exploiting kind of the first, second generation of uh, satellite technology that is out there, and this is just going to get even better. So, as LambdaI, we are mostly focused right now in AI and software, but actually we are already thinking about our own fleet of microsatellites or small satellites with very, very specific sensors that are tailored to specific use cases or specific industries, right? So in terms of what is possible, I think we're just looking at I think they're going to have an impact on so many ways when you start to have real-time data. Now we are looking at snapshots that happened, for example, a few hours ago, a few days ago. Think of real, real-time data in very high resolution, multispectral on every electromagnetic wave available. I mean, the possibilities of analyzing that data with even more powerful AI models. I don't know. I mean, I could think of so many things from, real time assessment of crops at centimeter resolution, where you basically could have automated farms with almost no intervention of people, because you have all the robotics, you have all the continuous monitoring with satellites, with even drones at some point would be even not so relevant, because you are having, even no matter what weather conditions, you have like centimeter resolution in using synthetic aperture radar, combined with AI in real time all the time. I mean,
It's like
think of
creating a digital twin, basically, right?
yeah, I mean, yeah, and that's thing. You have the digital twin, and you see the real time, and then you can really, adjust that, and then do the prediction. So the prediction is gonna get even crazier in the sense that you will be able to do a lot of, forecasting ahead, and definitely that is gonna help us also to manage this chaotic environment, which again is chaotic just because we are transitioning from one equilibrium state to the next one, right? Based on the conditions of the atmosphere. And just understanding that we're going to get from all these technologies that are flying out there, it's just going to make us even way better to manage it. So use cases, I don't know. I mean, things that we can do, there are so many. I think that is probably a topic for another podcast, or,
I may add for that, Sean, for part two, to answer also the other part of your question in terms of sustainability, what we I think see, I mean, in our view, as also insurance company and financial services in general, so banks might tie up the sustainability aspect. So, and using this participation new technology is definitely going to be a way to be able to monitor sustainability, right? We see some of the banks, for example, already, or some other financial services monitoring agroforestry, for example, right? And that's one area. And I think this will become, as we go forward, will become more and more relevant, detecting, for example, biomass, understanding the river paths, um, and it is something that we will probably start seeing more and more often.
Definitely. And very last question. When it's all said and done, what do you want people to remember about Lambda AI's long-term contribution to climate resilience and sustainability?
Well, I try to say it's basically our vision, right? So the ability of enabling and giving access to this fantastic technology that allows us to really be able to monitor our planet in a way um, that we basically was not possible before.
yeah, to that lines, I would like people to consider that we have been one of contributors to the catalyst. It's a kind of catalyst of the usage of this technology. So it was dormant very long time because of economies of scale were not the right ones, and suddenly, in a way, I think we are contributing to make people aware that, hey, right now you have access to this wealth of information, and you can get it. It's not prohibitive cost anymore. Look all the things you can do, and help our customers to really leverage that, and understanding and helping understand of the potential, and then what comes after that. and the vision that we have for really exploitation of all the the technologies that are coming. I think that is the thing that we probably may have an impact on the minds of our clients and people.
Gotcha. Really appreciate you guys sharing more about LambdaI Space. Really diving deep into like what this deep tech is doing to help us understand like what our agriculture is looking like at a very wide scale. So thank you, Antonio. Thank you, Raul, for joining me today.
Thank you, Sean. Very nice
Thank you, Sean, for letting us. Thank you.
Thanks for tuning in. If you enjoyed this interview, follow along on EarthABC's LinkedIn to stay connected and never miss what's going on in climate tech. If you'd like to reach out or you're interested in coming on as a guest, feel free to connect with me, Sean Pack, on LinkedIn. We're always looking for inspiring ventures and founders in the climate space to feature on the show. Hope you enjoyed. Until next time.